I've talked before about what it means for a strategy S to dominate another strategy T. It means that playing strategy S should always be strictly better than playing strategy T, no matter what the other players are doing. Maybe you were wondering why we choose this particular definition. Why do we require that S is strictly better than T? Wouldn't it be enough to just require that strategy S is strictly better than T in some situations, and then at least as good as strategy T in all other situations? In other words, wouldn't it be fine if strategy S is basically at least as good as strategy T, but it doesn't have to be strictly better in all circumstances? In that case, there also does not really seem to be any reason for the player to play T instead of S, right? Indeed, if we want to, we can define dominance in this way. I will call this weak dominance to distinguish it from our previous definition. So weak dominance is the following. Let S and T be two strategies of player I. Strategy S weakly dominates T if for any fixed strategies of the other players, the payoff to player I when using strategy S is at least as high as when using strategy T, and in at least one case, strictly higher. However, we have to take great care when we attempt to eliminate strategies based on weak dominance. Remember that we can eliminate dominated strategies in arbitrary order. The end result will always be the same. But for weak dominance, the order of elimination can matter, and it can result in different solutions. Consider, for example, the following two-player game in which the first player has 3 strategies and the second player has 2 strategies. And as always, I will write down the payoffs in this table. Can you see which strategies here are weakly dominated? Right. So strategies 1 and 3 are both weakly dominated by strategy 2. So which one should we eliminate first? Strategy 1 or strategy 3? So let's say we eliminate strategy 1 first. We cross that strategy out, and in the remaining game we see that strategy B now weakly dominates strategy A for the second player. We can therefore cross out strategy A as well, and we are left with a game that is not completely solved. There's more than one remaining outcome, but both remaining outcomes are identical in terms of payoff. Like in both cases, player 1 and player 2 both receive a payoff of 1. Okay, so this is one potential thing we could do. Now let's get back to the original game. So this time we decide to eliminate strategy 3 first. In the remaining game, strategy A weakly dominates strategy B. We can therefore cross out strategy B. And again, this game is not completely solved, but the remaining outcomes are identical in terms of payoff. So in both cases, player 1 receives a payoff of 2, whereas player 2 receives a payoff of 1. Note that this is a very different outcome to what we had when we eliminated strategy 1 first. The payoff to player 1 is now higher. So, in summary, our prediction depends on the order of elimination we choose. I would say that for this reason, the iterated elimination of weakly dominated strategies is not quite as convincing as a solution concept as the iterated elimination of dominated strategies. It is more fragile. In fact, in a later video, I will show you that eliminating weakly dominated strategies can lead to quite counterintuitive results.